Today in lab, we investigated what the relationship is between electricity and magnetism. In class, we learned that the magnetic field can be induced by running a current through a loop of wire. We wanted to investigate this phenomena further by changing the amount of current that is passed through the wire and changing the number of loops in the wire. The goal of the experiment was to calculate the induced magnetic field created by these varying conditions.
In our experiment, we plan to model this with a current source connected to copper wires. We will wrap the copper wires around the magnetic probe in order to measure the induced magnetic field in the loop of wire. We will change the number of loops as well as the amount of current supplied to test the strength of the magnetic field under varying conditions. I'm about to show you the setup of how our model was created.
Here is a video of our setup. As you can see, our power supply, our wires, and then Logger Pro.
In order to calculate the induced magnetism of a wire, it is important to look at the equation that is necessary to understanding this.
Our equation that we use. B loop represents the induced magnetic field of the wire, and it is equal to mu naught, which is a constant used in this equation, and N is the number of loops divided by the unit length of the wires. And then I represents the current. And these are all divided by 2 times the radius of the loop of wire.
We will analyze the data with Logger Pro to take experimental measurements of the magnetic field and then compare these results to our theoretically determined values. Logger Pro will provide us with an average magnetic field produced and a standard deviation for the data collected over a 30-second time interval.
As you can see, this is our data here. We have split it up into our theoretical calculations, meaning the correct magnetic fields that we should expect for each loop of wire with different lengths and different currents applied. And then we also have our experimental findings on the bottom. Now I'm just going to show you a simplified chart of our calculations. As you can see, we can see a general trend that the magnetic field does increase as you increase current, and also as you increase the number of loops in your wire. But as you also notice, there seems to be a lot of error in our calculations, and we believe this to be due to the large radius of the loops of wire that we measured. If we were able to get a smaller radius or use more loops of wire, it is likely that we would have had a greater chance of measuring a more accurate magnetic field. Another factor that could have also played a role is the fact that the loops were very clumped together and they were not uniform in their shape. So this also could have had some effect in our calculations. But mainly, we believe the large amount of error is due to the very large radius we use to try to measure the induced magnetic field, which we had already predicted to be a very small value.
So one thing that we found was that it was actually extremely difficult to measure the induced magnetic field with a small number of loops. The magnetic field that is produced from our experiment is very small, which makes sense given that our radius is very large, and in the equation a larger radius indicates a smaller induced magnetic field. We initially wanted to use the solenoid equation to calculate the magnetic field, but decided against it because a solenoid is a different shape compared to what our loops ended up looking like. And in order to keep the loops in a tight space for the probes to measure, we had to tape them together. This resulted in a shape that resembled more of a loop instead of a solenoid, and a solenoid is described as it going to infinity, and therefore it made more sense to use the loop equation for our experiment. In a future experiment, though, we should use a smaller wire that, although might not be able to handle as much current, we would be able to wrap it directly around the probe to get a stronger reading, and therefore we would be able to decrease the radius and increase the magnetic field produced. I think it would be interesting to see if decreasing the radius of the loop would make the probe's measurements more accurate.